My name's Joe Bagley. I'm the CTO for EMEA. Anyone here go to VMworld this year? Right, you'll have seen me as the guy who plays the double act for Carl on stage, which was not fun. It was, actually. It was hard work, though. So this is me on my own now, without being formally scripted by the marketing people. So you'll hear a bit more than the formal scripting by the marketing people. Though, to be honest, those of you who did see that, a lot of it was ad-libbed. There were whole sections in the speaker notes that just said Joe and Carl chat, and that was it. So, and we deliberately tried to trip each other up. So, as Lisa said, I am the CTO for EMEA. There's another one in the States, Paul Strong. And yes, I started in operations. I started in IT support over 20 years ago now, which feels like a long, long time. And I've been at VMware for 3 years. Before that, I was the CTO for a company you may have heard of called Quest Software, and helped build that company before it was sold to Dell. And what does it mean to be a CTO? What does it actually involve? Well, a lot of people seem to think it's all sort of rainbows and unicorns and talking about wonderful things and having a great time. And to be honest, it is, to an extent. You get to meet some interesting people. And you get to have some really fascinating conversations about what's going on. But at the same time, people expect you to be this kind of soothsaying visionary, I suppose, really, you know, being able to see into the future. And it's not really quite like that. Because to be honest, if I could see that well into the future, I wouldn't be on this stage right now. I'd be on a boat in the Mediterranean, right? Checking out my millions. Or minions, whichever I decide to have. So, part of my role, working with Paul and Carl and Pat, is what's next? What's next for VMware? What's next for our industry? Where are we all going? Because we have to make sure we're one step ahead of you. Because we have to make sure, bear in mind that we're working on vSphere 6 and the roadmap around vSphere after 6 and all the bits that sit on top of that. Because these things don't just suddenly happen. There's a lot of planning that's involved. And so we're asked to predict. Now, a very famous, reasonably local physicist called Niels Bohr is famous for saying that prediction is very difficult, especially about the future. And it's true. We can only go on what we knew before and what we think might happen. The problem is that if you look back in history, human beings are really, really, really bad at predicting the future. I give you an example. The flying car. The flying car has been predicted for a very, very, very long time. In 1924, people were saying that we should have the flying car within a few decades. Now, a few is 3 or 4, right? So we should have lots of flying cars by now. We haven't even got, you know, widespread electric cars yet, so we've got a long way to go. But specifically about technology, prediction is really interesting to me as we study markets. And I was asked a very strange question yesterday by a panel of customers. And it was kind of, you know, what makes it exciting for you in your job? And I'll tell you what makes it exciting for me in my job. It's the same thing that makes it exciting for you in your job. It's always different. There's always change. There's always new stuff coming. What you're doing today, the technology you're working on today, will be very different to the technology you were working on 3 years ago, which will be very different to the technology you'll be working on 3 years in the future, unless you work for the government. In which case you're working on technology from 15 years ago anyway, so that's fine. Realistically, though, the change is really, really important and very exciting. The problem is we still haven't worked that out as an industry. Also, people tend to get stuck in their ways. So here's a great slide for me. This is someone in 1968 saying that there's enough cars in the United States market that the Japanese will not be successful. Does that remind you of any technology companies or marketeers at the moment that tell you that, you know, we're so well established, no one can beat us, we're too big to fail, we don't need a new operating system, we don't need a new cloud, we don't need a new anything? And we remind ourselves of that at VMware a lot as well, because you can very easily get a little bit blasé, a little bit casual about what is coming. So if we look at this, this is quite a good one. This is someone telling you that if it was ever possible, and it isn't, to transmit voice over wires, it would be of no use. Why would you ever want to transmit voice over wires? And of course, we know that that was something that became reasonably popular, transmitting voice over wires. And then someone said, well, we can transmit it without wires. And of course, a very famous English physicist said that's really got no future. No one's going to want to use radio. Why would you use radio? And all the radio guys went, you're stupid, you're stuck in the past. Everything is about radio now. And then very shortly after that, the radio guys were caught saying, television's a waste of time. Radio's everything. So bear that in mind as you listen to vendors, as you listen to pitches from people telling you that either, yes, this is the future, much as I will give, or this is not the future. What we have now is good enough. And that is unfeasible. I know I've tried. Well, just because they've tried doesn't mean other people can't do it better. And so as we sit now in this world of change, we look back, and I look back in history at my father's days of computers. For those of you who don't know, my father was the product manager for VM at IBM. So I'm a second-generation virtualization product guy. I think the only one in the industry. Sunday lunch is very interesting at my house. If you're a geek, that is. If you're not, it's not interesting at all. So the mainframe. The mainframe is interesting because to me that's where the term user came from. We're called users because in the mainframe days, the IT department owned the mainframe, and if you were lucky, they let you use the computer. Aren't you lucky? We're going to let you use a 3270 terminal, right? You can use our computer. Much, much more about control than anything else. And then the business fought back. The IT department got fed up, sorry, not the accounts department got fed up with waiting to use the mainframe. And then IBM came out with something called the PC. And there was a killer app for the PC, which was VisiCalc or Lotus 123. And so then we entered the world of client-server as these devices appeared, and then everyone in IT went, whoa, that's a computer, we should control that. And so we then had years of networks and Intel LAN desk and SMS and God knows what else, trying to get that stuff back under control, which in most cases made it worse, as we know, right? If you want to see the same thing today, look at mobile device management. It's the purest form of get it under control and break it, right? And so we went through this cycle, but what's happened is, in that, we built competencies. You guys all grew up in this. The fact you're here means that you probably are, if not consider yourself, an expert in the world of client-server. A senior infrastructurist, if you want to look at it that way. Then we have the silos. We have the computing silo, the network silo, the security silo. They're the guys with the tinfoil hats, a bit weird. You have the storage guys, and so on and so forth. They're areas of competence. That's all broken now. Because now we're entering into what we've termed the mobile cloud era. Other people call it the post-PC era. I think the best thing to call it is the we have no idea what it's called era. Okay? And this is fair enough because the Victorians didn't call themselves Victorians, right? In the UK. You don't call yourself that when you're in the period. It's when historians look back. So I'm wondering what, in 30 years' time, my daughter will be standing on this stage calling my crappy technology from 30 years ago. But right now, we're in this really interesting world. And the fun thing for you guys is, nothing you did in the middle will work in this future world. It's utterly different. We now have billions of users, millions of apps, data on a scale that you've never, ever dreamt of. Now, if I'd stopped a man in the street 10 years ago and asked him, what is a gigabyte? He might have known. Now, today, he will definitely know what a gigabyte is. Why does he know? Because he buys his iPhone in gigabytes. Yeah? You buy your apples in kilos, you buy your iPhones in gigabytes, right? It's the same thing. I have 32 gigabytes of iPhone. That's what my mother says anyway. But would you know what a terabyte is? Probably, because you can buy a terabyte for 60 euros or 70 euros from the PC store. We in IT have started talking a lot more about petabytes now. Duncan Epping, who's currently on a plane right now, will tell you that with vSAN we're looking at 1.1 petabytes on 280 disks across 8 nodes. That's pretty scary, right? 1.1 petabytes in local storage. And just to put that into context, the interesting one for me right now is the exabyte. Now, let's put the size of an exabyte into context for you. If everything every human being had ever said, and yes, that's cavemen saying, look, big mammoth, right? Had been written down and stored, 5 exabytes. 5 exabytes. So let me tell you a story. Because this isn't prediction, this is looking back. You can do your own prediction. In 2005, after 20 years, EMC had sold a total of 1 exabyte of disks. So by 2005, they'd sold an exabyte, 1,000 petabytes, 1,000,000 terabytes by 2005. It took them 20 years, but they did it. That's pretty impressive. That's a pretty big number, right? 2010, they sold an exabyte in 1 year. They went from 20 years to 1 year. It gets better. In 2011, they sold an exabyte in Q3, in 3 months. So the data that we're storing is going up in ways we wouldn't comprehend. Best bit for me, in June 2003, they sold an exabyte in 1 month. 1 month. They shipped 85 petabytes in 1 order to 1 customer. It was 18 articulated trucks of storage turned up to that 1 customer. 85 petabytes in 1 order. 1 exabyte sold in a month. They're now looking at their first exabyte customer, probably in the next year. We've got bets within the management team as to when the next or the first exabyte week is going to be for EMC. And EMC is about 30% of the storage market, so that gives you an idea of how much people are using. Now, what is all this stuff, right? Because it's not all selfies and Instagrams, right? And pictures that Simon Gallagher takes of himself, right? It's not. What it is mainly machine-generated data. And everyone talks about the Internet of Things. You own an Internet of Things. You will run an Internet of Things. You want to know machine-generated data? Event logs. Just think about that. The event logs your machines are generating, they're machine-generated data that people want to store and analyze. And if you take it up to the full extreme, a 777, a Boeing 777, in 1 transatlantic flight, it's got 15,000 sensors on it and generates 36 gigabytes of data in 1 flight. The new 787 has 100,000 sensors on it. So you can only imagine the data that's going to generate in 1 flight. A lot. And so we have to come up with new ways to deal with this. Because I can tell you right now, I can't take 85 petabytes of data and put it in 1 relational database. Oracle, SQL, or otherwise, right? It's just not going to work. These models are broken. And at the same time, we have a problem in technology. So this is a motherboard, for those of you who don't know. For those of you who are real geeks in the audience, you'll notice it's the motherboard from a Commodore Amiga. The point here is that storage is getting closer to the processor. And if you think about it, it's where it should be. Because way back when, storage was a long way from the processor. It was on punch card, and then on tape and disk and so on. It got closer and closer. In the mid-90s, we nearly got it back, right? Remember the compact 4500s with the inbuilt RAID arrays and stuff and the RAID controllers, right? We nearly got the storage back. And then the industry took it out into SANs and NASes. But the dream for a computer scientist is unlimited fast storage right next to the processor. And that's where we're getting to. Because now we have SSDs in local machines. Most of the machines that you'll order in the next 5 years will have SSDs in them. Better than that, we have SSDs now plugging into PCIe slots. But even that's rubbish compared to companies like Diablo Technologies, who will sell you SSDs on DIMM socket plugs. Yes, putting SSDs into DIMM sockets. Why? They're faster, and there's more of them than a PCIe socket. And then if you look at stuff like rack-scale architecture from Intel that's being talked about, there is no real concept of separate storage. It's all just one big lump of processing and storage in one great big rack. And then we get to problems with the speed of light. Now, light is really fast, isn't it? Yeah? I mean, really fast. Light, by the way, is faster than sound. It's why most people look intelligent until they open their mouth. Okay? So if you look at 1 nanosecond, now 1 nanosecond, that's not a very short period of time, is it, in our lives? That's 1 gigahertz, 1 nanosecond. In 1 nanosecond, light travels how far? 30 centimeters. So if I've got a rack with light connecting the top to the bottom, that's 6 nanoseconds. I can't get better than 6 nanoseconds delay. And if I'm building processors and RAM all in a rack that are like that, I have to start dealing with the factor of 6 nanoseconds, which granted is less than the 15 nanosecond Q1 delay on a chip today, but it will cause problems in the future. But also we have a problem with heat. And the simple P equals V squared C tells us that we cannot generate much more heat than we are or push much more power through processors. That's why we have multi-core. And so the future for computing isn't build bigger and faster chips, it's build more of them that talk to each other in an intelligent way. It's a scale-out world. And these two trends really are monolithic applications moving to distributed services and loosely connected discrete resources moving to a virtualized fabric of resources. That's exactly what's happening. But we can't do this using all the ITIL stuff that we learn and built in these silos in client-server world. So at VMware, we're focused on 3 areas. And this is the only sales slide, right? The software-defined data center, which you may have heard us talk about once or twice. Hybrid cloud and end-user computing. 3 areas. Now, when we ask our customers what they want from the future when they come to us and have these futuristic conversations, they tell us they want hardware-agnostic and elastic scalability, dynamic resource assignment, they want applications and services on demand, they want a fully automated ecosystem, and a pony and an ice cream, right? They want everything right now. But if we try and summarize it all up, we're basically down to a self-service infrastructure that conforms to enterprise IT requirements. Simple, huh? You could build one tomorrow, right? No problem. Well, it's not that easy. So when we talk to our customers, we see there's 3 stages that you're going to go through. There's the IT production, then the business production, and then true full IT as a service. And those 3 stages, the numbers at the top are where our customers are right now. So you can identify which stage you're in. I've put up here the kind of programs that might be going on. So the first phase 1 is just the standard virtualization. You've got it there, server consolidation, test and development. It's not very difficult. It's, do you want to run 10 servers on one server? Yes, please, right? Not a hard one to do. Followed on for that is the tricky one where most people are. This is where you start to move more business-critical apps onto that platform. You start to take advantage of availability in software, not availability in hardware. Start using things like HA, fault tolerance, etc. as part of your architecture. And you have automated management. More importantly, security forms part of that game. The hard one is the one over here, the on-demand, self-service, automated provisioning, self-program, blah, 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 blah. Woo! Right? Quite difficult, but it's where we're all headed. Number of servers per admin. Quite amazing, really. Now, let me tell you this. This doesn't mean that 1/3 of you are going to lose your jobs. Not at all. It means that when you get to that stage, your company will have 3 times as many servers, if not more. So don't panic, all right? We're not automating your job away. We're actually helping you cope with the future. So let's talk about the software-defined data center, this term. Everyone talks about the software-defined data center. I'm quite proud of the fact that we at VMware, there's various arguments as to where the term officially came from, whether it was Raghu or Steve or some others of us with Raghu and Steve in a bar drunk or what, we're not really sure. But it definitely came from VMware. And now the whole rest of the industry wants to tell you that they're into software-defined data center, which is certainly something. But let me tell you the golden rule that we as the definers of the software-defined data center laid out. It's very, very simple. In a software-defined data center, everything is done in software. Everything is done in software. Now, what does that mean? That means if you go and talk to a vendor today or any other day, and they tell you their thing is a software-defined thing, but to use their software-defined thing, you have to buy a specific piece of hardware, it's not a software-defined thing. It's a hardware thing with software-defined t-shirt on, okay? It's not a software-defined thing. The future is truly where all of the intelligence, networking, storage, compute, security, availability, everything done in software. And underneath that, commodity hardware that we really don't have an interest in. This is the challenge and change. As we watch entire industries try and let go of hardware. Those people who've built computers their whole lives realizing that no, our computers are now going to be built by a few companies. They will arrive as white boxes. We will do all the fun stuff with software on top of that. So just remember that. If they tell you that the software-defined thingy they're selling you requires you to buy a hardware thing, then it's not a software-defined thing. And to put that into context, let's look a bit more at the software-defined data center. What we've got here is both network security, compute, and storage and availability all being run and managed in software through an abstracting and pooling layer. Now, for us, that's vSphere and NSX and vSAN. Up here, policy-based control and automation of those services, and then the necessary operations management and automation. And if you follow history well, predictions are not difficult. This will become more and more commoditized. It will become more and more built into the product. And in the future, up here is where you will be spending your time and adding your value as a VMware administrator. Not down here, up here, as time moves forward. And if you look at how we answer those four things people are asking for, they're all right there. Hardware agnostic and elastic. That's the I don't care what the hardware is, and so on and so forth. So, as we go through this world of abstracting, pooling, and automating, I think we've done compute pretty well, right? Not bad. I'd say we've got a pretty good hypervisor. It's fairly capable. It runs, governments run on it. ESX runs pretty much everywhere. I think we've pretty much done on compute. These next two pieces are where we're going. And it's going to be an interesting fight. But I'll tell you now, we're not focused on our competitors. We're not looking at them. We're looking at our customers. We don't step forward as an industry by me looking at the person next to me and saying, oh, they've done that, I'm going to do this. It's looking at you guys out there and asking you what you want, and then building our product roadmap based on that. So that's why I'm going to stay here all day and all evening. Please come and find people from VMware. Talk to us. Tell us what it is you want to do here. And I don't want to hear, so-and-so does this, so why are you going to do that? I want you to tell me the reason why you want us to do something in technology, because that's what drives me. So how does this network thing work? And hence the Run NSX t-shirt. So NSX is a very interesting technology. And it's the biggest challenge for me and a company to explain to people how it works. It is not, and I will say this again, it is not getting a router and putting it on a virtual machine. That is not the future of networking. It is not getting a switch and putting it in a virtual machine. It's not getting a firewall and putting it in a virtual machine. It is getting the functionality of a switch and a router and a firewall and a load balancer and putting that into the machine. That is what the future of networking is. Now, in your data center, the machine, the layer that sits across everything, is the hypervisor. And so we're taking, from a pure computer scientist perspective, the functionality that you previously handed over to network guys, giving it back and putting it in your machine. So how does this play out? Well, if you had a couple of VMs, and those VMs want to talk to each other today, they go across some switches, some physical switches. Now, as some of you know, it's not as simple as that, is it? Because you have to go to the network guys and have a conversation about them, please, 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 please give me a trunk port. Right? We've all been there, yeah? It's like them handing over their children, you'd think, when you're trying to get them to give you a trunk port so you can start to do VLAN stuff yourself. They don't trust you with this thing, right? You're just a geek VMware guy. You don't understand networking. It's very, very hard. I'm a CCIE. I had to do an 8-hour practical to be able to type at this console. You don't understand. I'm a CCIE as well, so it's not that bad. So, seriously, right? Thing is, you then bring up another VM, and it goes through different switches, which is fine. They've probably got a really good reason for that. But it all had to be configured manually. The VLANs had to be set up manually. All the routing and the switching has to be set up manually. Well, what if we just took the switch functionality and we put it all into the hypervisor? That's exactly what we're doing with NSX. So now, all the switching intelligence is done by the hypervisor. These things in the middle, they are grayed out for a reason. They are now, I don't care what you are, just take my IP packet and get it to over there as fast as you can boxes. Right? Network guys don't like this. Network vendors don't either, okay? Well, quite a lot of them get it, a couple don't. So once you've done that, we'll then go, okay, let's try and do this for routing, shall we? So let's have a look at what happens with routing. So if I've got two VMs here, and they're on the same machine, but they're in different subnets on different VLANs, and I want a packet to get from one to the other, well, guess what happens? That packet goes out to the router in the network, which then sends it back again. Now, if I even show that to my mother, she says that's silly, right? She's also a CC. No, she's not. Okay. Now, it's not just that, but all of the routing intelligence is in the network. And the answer they'll give you to, we need a faster router, is, okay, we'll buy a bigger router. Not the answer. The answer for us is to get all of that routing information and intelligence and move it into the hypervisor. Now, traffic stays local if it needs to. As a future idea, and this is no product promise, but imagine if DRS had network affinity. Imagine if we moved VMs around based on how they talk to each other. That'd be pretty cool, wouldn't it? And in fact, when we did some research, in fact, we didn't, Cisco did in 2011, they found that over 70% of traffic in a data center is east-west traffic. It's traffic between servers. It's not in and out, it's within. And so if a lot of that can be reduced, and more importantly, managed better, it's going to be better for everyone. Now, let's talk about firewalls. Firewalls are great because if I want to get out, the packet goes out, hits the firewall, and that's where it gets discarded. Well, what if I moved all the firewall functionality into the hypervisor? This time, the packet will get discarded before it even leaves the host. And in fact, the concept of a firewall goes away. There is no firewall. There's rules around the flow of information. I may say that the grey VMs are in the web tier, and the purple VMs, I think they're purple, whatever, the other color, doesn't matter, are in the app tier. And the web tier and the app tier can only talk together on these 3 ports. What does it mean in this world? Wherever you move those VMs, anywhere in your environment, those rules will apply. And yes, you can have 2 machines on the same subnet in different data centers, on different physical VLANs. Doesn't matter. As you'll notice, this bit down here is grayed out. Not interesting. The physical world, not the important piece. We're doing everything up here now, including even load balancing. That's also done in that network layer. So like in compute, when you look to the future, you see a future where you buy an x86 server and just rack it up and then put ESX on it and do all the interesting stuff. The same for networking. You'll have one top-of-rack switch, probably with 10 gig E-connections down to all of those servers. And all of the intelligence in your network will be in those servers. What's nice about that? When I buy a new server, I've expanded my network capability and my network intelligence. Every time I buy a new server, which by rights puts more load on the network, I'm also increasing the network's capability to do things. And in that example I just gave of where we move these VMs around and the policy follows with them, just imagine that compared to what you have to do today probably in your environment. When you want to move a VM from one data center to another, and the conversations you have to have with people about PICS configuration and VLAN reconfiguration, and they tell you they can't do that until next June when they get an upgrade, and the firmware upgrades are at the same time as the server upgrades, and everything else is right. And so we'll allow you to vMotion that server next June if you're really nice to me and get me coffee a lot, right? Changes. Point being that it changes from days to minutes to configure all of the network stuff. Now that's pretty cool as a concept, right? In fact, I think it's really cool. I think it's revolutionary in what we're doing for the industry. And we're going to do the same for storage. And that's vSAN. And you've got Duncan coming later today, so I really recommend you go and see his session on vSAN, because this is really quite interesting. What we're doing here is we're saying, across all these x86 servers that you're buying that are also going to do the networking with the 10 gig E cards in the back, just put some SSDs and some spinning disks in them. And then we'll build you a SAN out of all of that local storage. That's exactly what we're going to do. The moment supports 8 nodes. I think it's 280 disks total across all of the servers. And it's fast. We did some testing before VMworld this year, which actually had it performing better than some all-flash SSD arrays. Because don't forget, we've got flash actually in the host, which is doing right through cache, which is really, really, really cool. And really, really, really fast. So now what does your future look like? Now your future looks like you are racking up an x86 server with some SSDs and some disks in it. Don't care who made them or what they are, even the server. Rack it up. 10 gig E, plug it into the don't care what it is, Cumulus Networks, not really bothered, switch at the top. And then everything is done in software. Abstracted, pooled, and automated. Now, for the last 5 minutes, I'll go through what the future holds for you after you've built this infrastructure, or more importantly, why you're building this infrastructure. You're building this infrastructure because this is the world we all know. Enterprise 3-tier apps, traditional SAN NAS storage. Not the world that you will have in 5 years' time. In 5 years' time, you're going to have a variety of new platforms come up. You're going to have all of these scale-out flash storage requirements. You're going to have Hadoop. You're going to have Python. You're going to have Node.js. You're going to have Voldemort. Voldemort. There really is a network database called Voldemort. It's the version of Cassandra that LinkedIn runs on, actually, if you really want to know. All of this stuff is going to come as your company decides it wants to write new apps and be more agile, et cetera, et cetera, et cetera. And that's going to require a whole bunch more infrastructure. So your SSD arrays, you're also going to have things like server direct attached storage. You're going to have object and blob stores. And things like virtual SAN, bringing that all together across all of those nodes. It's going to get mad. And you need to understand how to do all this stuff. Because when you look at those workloads, on the right there you've got the old style workloads. You've got your traditional business critical apps. But on the left you've got a lot of stuff coming. And you really have. And if you don't think you have, you're lying to yourself, and in 5 years' time you will have. So now you need to learn. And so to finish up, it's time for the animals, I'm afraid. Sorry, guys down the front. Here's what's really going to change. Because as you can probably tell, the way you manage hundreds of racked servers with local storage and white box networking is very different to the way that you manage your infrastructure today. And this is where, done that, there we go, exciting. This is where the cat comes in, okay? Now some of you know the cat, some of you don't. This is the cat. This is one of my cats. It's Bellatrix, actually, is its name, believe it or not. And back there is the other friend cat, that's Luna. My kids like Harry Potter, what can I say? Why have I got a cat on the screen? That's because that's how we manage servers today. Not with cats, right? But like cats. If we go and look at the servers that you guys probably have, think about this. Each of my cats has a name. Each of my cats has someone who looks after it. We go and look at the cat and we stroke it. We show the cat off to our friends. We maybe take pictures of the cat and take it to conferences to show to other cat people our lovely server. We do Visio diagrams of how we configure the cat, and we share them with friends on how lovely my cat is. When my cat is ill, I take my cat to the vet and I spend a lot of money and a lot of hours trying to fix cat. Sound like your servers at all? The only difference is my cat doesn't have an IP address. It probably will do in 5 years' time. I'm just about to fit a cat flap that is based on the chip in its neck this week. That's quite cool. So only because I did come down one morning and there were 7 cats in my kitchen. None of them were mine. So if you think about how you manage your servers today, they're managed much like cats. They very, very much are, okay? But in this future world, you're going to have not 5 cats, 10 cats to manage individually. And I bet you could tell me the IP addresses of your servers, right? The ones that you manage. If I asked you, you could probably tell me the configuration, what patch levels they are. In the future, in this world over here, you're going to have hundreds, thousands of servers. Now, I don't know about you, but if you've ever tried managing hundreds or thousands of cats, it gets messy, right? Very, very fast. So you need to change your mindset. You need to start thinking like a chicken farmer, okay? Now, my friend, who, like myself, is also a theoretical physicist, okay, seriously, ended up as a chicken farmer. This is the career path for theoretical physicists, I've decided. You become a TV celebrity stroke pop star, or the CTO of a software company, or a chicken farmer. I'm edging towards chicken farmer, okay? He has 15,000 chickens. It was 14 and a half, but he's got 15 now. I can tell you right now, none of them have names, okay? No one comes to his farm to look at his fluffy kittens or chickens. Not interesting. More importantly, if one of the chickens isn't working properly, doesn't go to a vet. And if you ask him what he does, he doesn't manage chickens. He produces eggs from thousands of chickens. And I can tell you, you can use ITIL and Six Sigma to manage cats. You can't use ITIL and Six Sigma to manage chickens. It doesn't work. Someone is going to come to your office one day and want to create 100 chickens. And he wants you to store them in the same data center as your 50 cats. Putting chickens and cats together? Not a good idea. Or is it? Because when you go through this change, this focus where you go from individual siloed stacks of kitten management to the future of chicken management, you're going to need to change the way you think. And really what you're going to need to change is realize that in the future you're going to have a world that looks like this. At some point, someone is going to come to you and say, I'm going to do my dev on Amazon. I then want to move and do my testing on your internal vSphere cloud. I'm going to be spinning up and down 400 VMs a day. Is that all right? And then they're going to move it to a public vCloud to run it. And you're going to sit there and go, oh, my network guy's not in until next Thursday. And to be honest, he's going to be pissed, right? Not going to work. Can you imagine creating 100 servers and configuring up the networking and storage for 100 servers on demand, twice an hour? Not going to work. You need a new way of doing things. And to be honest, that's what we're building at VMware. We at VMware are building a world where you can have your traditional applications running. Fine, no problem. But also the world where you can have your future applications. We're building a world where kittens and chickens can live together. It sounds like a party political broadcast, right? We're building a world where kittens and chickens can live together in harmony. Seriously. As you change from being cat people to chicken people over the next 5 years, we're going to be there for you. Because the thing is, the kittens aren't going away. They're staying. I sat with a customer the other day that told me they were just starting proudly told me they were starting a new 9-year SAP rollout project. 9-year projects in IT. Who does those? Some of you are nodding. I feel for you. Okay. Still keeps you in a job. So, remember, guys, what you need to be working for is that this future of a software-defined data center, all of the infrastructure services are delivered as software, and the control of that is entirely driven by software. And I'll leave you with one last comment. I had a friend recently, or it was one of our SEs in the UK, who came up to me and said that his customer had phoned him and said, "Hi, next week you're coming," this is a true story, "next week you're coming in to do the virtualized networking POC, right?" Yeah, of course I am. Okay, what are you bringing with you? And our SE goes, "My laptop, some software on my laptop, a couple of URLs to download some stuff to my laptop, and we'll do the POC." He said, "That's interesting, good. Why do you ask?" "Well, our existing network vendor has just turned up to do their network virtualization POC, and they've delivered 40 boxes on 4 pallets. I can't see the virtual bit next." Our SE gave the best answer ever. I don't know whether he did, this is what he told me, he said. He said, "Don't worry, leave it all there. We'll run all our stuff over the top of that as an overlay." So, as you go forward, think about how you're going to change your company to be software-defined. How you're going to lead the network guys through the world of virtualization. How you're going to help the storage guys through virtualization, because you are the leaders in virtualization. You here at VMUG invested your careers. You bet yourselves on VMware. Some point in the last 10 years, you looked at VMware technology and didn't only think, "Hey, that's pretty cool. They must be amazing guys I want to hang out with." No, you didn't, right? You looked at VMware technology and said, "Hey, that's pretty cool." And at the same time, you thought, "There's a future in this, and I'm going to bet my career on it." Well, I'm asking you again to build on what you've done, to take what you've done in the last 5, 10 years, that knowledge, and bet your future again. That we're going to do this to networking, we're going to do this to storage, we're going to build those future large-scale infrastructures for those future apps. And you guys here are the leaders in your field and in your companies in taking that charge. And so with that, I wish you a good day, and I hope you enjoy the day you have at VMUG. Now, what we're going to do next is, I believe there should be a break. We started 5 minutes late, so I'm 5 minutes over. I'm sorry about that. And so those of you meeting for the Norwegian VMUG meetup, it's now 10:10, not 10 o'clock at the VMUG stand from the slide before. But please, guys, go to a session today that you weren't going to go to. If you're not a networking guy and you thought, "I'm not going to bother with the NSX piece because I'm not networking," go to the NSX piece. If you're not a storage guy, go to the vSAN thing. Because in 2 or 3 years' time, you are going to be the storage, networking, compute, and management. And if you all go to learn something today, go and learn about vCloud Automation Center, because that's what's going to hold this all together. All right, so thank you very much, guys. Enjoy your day and enjoy your coffee break. Cheers.